Tesla bot Gen the 3rd of May come in two versions, one in yellow like this and one in black like this, and it will be quite different from Optimus 2.5. The launch event could very well take place as early as this April. Yeah, Elon Musk has confirmed the progress of Optimus 3, and it's in the final stage before being ready to appear in public. It will likely be similar to the Wii robot event held in 2024, where people could interact and watch demonstrations by Optimus. Of course, after nearly 2 years, the engineering and design of Optimus 3 will be far more advanced than Optimus Gen 2. You can see just how big the gap is by looking at the hands alone. So what's going on with Optimus 3, and why is Elon so confident about this version recently? When asked why Optimus 3 wasn't launched in Q1 as expected, Elon Musk said on X Optimus 3 is walking around, but needs some finishing touches before it's ready to be shown. This aligns perfectly with what angel investor and entrepreneur Jason Calacanis revealed. He said he saw Optimus 3 at a Tesla factory and believes it could be the most groundbreaking technological product ever created in human history.
And I saw Optimus 3. I can tell you now, nobody will remember that Tesla ever made a car, and it is going to be the most transformative technology product ever made in the history of humanity.
Yeah, we already know quite a lot about the standout features of this new version, even though it hasn't officially launched yet. Elon Musk and Tesla's engineers have recently emphasized that Optimus Gen 3 is getting closer to human form and functionality, even though we don't really want to repeat ourselves since we've mentioned it many times before. Every time we look at Optimus 3's hands, we can't help but wonder, how were they able to create hands like that in less than 2 years? They actually managed to build a 22 degree of freedom hand in just 2 years, one that really doesn't fall short of a human hand. That's something most competitors haven't been able to pull off. It'll let Optimus handle a wide range of tasks with incredible precision. Tesla definitely has the right to be proud, because the hand is one of the toughest engineering challenges in robotics today. It's kind of funny. We're pretty sure Elon Musk has pointed this out at least 10 times in talks and podcasts. People often say it's half the engineering problem, but honestly, we think it's even more than that. You can build a dexterous hand, or you can build a strong, durable one, but making a hand that's both dexterous and tough is really hard. We've seen highly dexterous robot hands before, but they'd probably break down under everyday use. Beyond the hand, Optimus 3's movement capabilities and speed are also worth paying attention to. Looking at footage of Optimus 2.5 from a video posted in December, it showed the Tesla bot could run at an estimated speed of up to 6.8 miles per hour, with running form about 90% similar to a human, according to Dr. Scott Walter. What's even more impressive is that, even as version 2.5, each stride looked very natural, and there were moments when both feet were almost completely off the ground. That's actually pretty similar to how human biomechanics work when running. So what does a running speed of around 6.8 miles per hour really mean if you break it down? That suggests a walking speed somewhere around 4 to 4.5 miles per hour, or roughly 1.8 to 2.0 meters per second. Typically, a humanoid robot only needs to move at about 2.5 miles per hour to be useful around a house or factory. So if Optimus 2.5 is already hitting 4 miles per hour, it's not surprising that Optimus 3 could go even faster. Now, everyone probably already knows this, but it's still worth repeating. Tesla's Optimus Gen 3 will have Grok voice, and in fact, it's already been officially integrated since mid-2025 in version 2.5. Elon Musk has also confirmed this when asked whether Optimus would use Grok as a voice assistant. Grok, the advanced AI model from xAI, acts as the conversational brain for Optimus 5.3, enabling much more natural interactions. Instead of just following rigid commands, the robot can now understand and handle everyday conversations intelligently. From something like, grab me a glass of water and tidy up the table, to more complex tasks that require contextual reasoning. Sure, response speed might still need some improvement to feel perfectly smooth, but it's definitely a must-have feature. Honestly, a lot of people wouldn't enjoy a robot that can do everything but can't hold a conversation. It'd feel pretty dull. On top of that, some tech outlets are reporting that Samsung Display is expected to supply 8-inch OLED panels to Tesla starting in 2027. There's speculation that these could be used as a facial display for Optimus Gen 3 since its face has a hemispherical, human-like shape that works well with flexible OLED, thin, lightweight, power-efficient, and bendable, which is hard to achieve with standard LCDs. This kind of display could show emotional expressions, communication cues, or just make the robot feel more approachable to humans. That said, this is all industry speculation. There's been no official confirmation from Tesla. Honestly, we don't think it'll happen, mainly because it would drive up the cost of Optimus. But at the same time, it does feel kind of necessary. right? So what do you think about Optimus 3 having a display on its face? Is it actually necessary? Like we mentioned in a previous episode, Optimus Gen 3 will almost certainly be designed to handle a range of weather conditions, which also means some level of water resistance. Elon Musk has hinted that the robot will more or less have this capability. Various reports and analysis from Tesla engineers suggest Gen 3 will feature better sealed joints, a polymer shell covering around 70% of the body, and improved sealing in the hands to handle rain, steam, soap, and general indoor humidity. Of course, that doesn't mean it's fully waterproof. You wouldn't be able to submerge it or use it continuously in heavy rain like an IP68 rated device. Optimus Gen 3 isn't meant to be a full-on all-weather industrial robot, but it should be water-resistant enough to function as a practical home assistant. Even though everyone knows training humanoid robots requires massive amounts of data and complex real-world environments. Tesla's Optimus Academy is the breakthrough solution that Elon Musk has hinted at, aimed at turning Optimus Gen 3 into a truly intelligent assistant. This isn't a traditional school, but more like a large-scale real-world academy where tens of thousands of humanoid robots learn, practice, and improve their skills through self-play in physical environments, tightly combined with ultra-realistic simulation. According to Elon Musk, Tesla plans to deploy at least 10,000 robots, potentially scaling up to 20,000 or even 30,000, constantly testing different tasks, from household chores like cleaning, cooking, and elderly care to more complex industrial work. The goal is to create a closed learning loop where robots don't just follow commands, but also explore, make mistakes, and optimize their behavior independently. At its core, Optimus Academy combines two main learning approaches, learning from humans and learning from instructional videos. In the early stages, the simplest way to train Optimus is through human demonstration. The Optimus Lab is located in a glass-walled building at Tesla's engineering campus in Austin. Inside, dozens of workers wear motion capture suits equipped with 5 cameras mounted on their helmets, along with a heavy backpack, working 8-hour shifts to train the robot. Their job is to repeatedly perform hundreds of everyday actions, lifting a glass of water, wiping tables, opening curtains, walking, running, dancing, or even simple industrial tasks. Every movement is carefully recorded to build imitation learning datasets for Optimus. This video data is then fed into end-to-end neural networks, allowing the robot to learn how to move, grasp, and interact with the physical world more naturally. This marks an important transition for Tesla. In the past, the company relied heavily on teleoperation to train robots, but that approach is slow and difficult to scale. Even small data collection tasks can take weeks, and Tesla reportedly paid around $48 per hour to workers wearing motion capture suits to generate training data for Optimus. However, this is just the initial phase. By the time Optimus is fully commercialized, it should be able to learn new tasks on its own without requiring users to train it. At that point, Optimus will be capable of learning from videos on the internet, though those videos will need to be curated by Tesla. For example, it could watch tutorials on how to use a microwave, stir a pot, clean floors, or even perform kung fu movements, then imitate and adapt them to its mechanical body. Tesla has already made significant progress in transferring knowledge from both third-person and first-person video perspectives to robots, allowing Optimus to rapidly acquire skills without step-by-step programming. This approach is powered by a strong sim-to-real transfer pipeline. Tesla has developed a highly accurate reality generator, similar to what it uses for self-driving cars, to create millions of virtual robots in simulated environments. In simulation, robots can safely test billions of dangerous or rare scenarios without any real-world damage. Then, data from tens of thousands of real robots in Optimus Academy is used to close the sim-to-real gap, fine-tuning models, so behavior in simulation closely matches reality. The result is a system where robots learn dramatically faster than relying on limited real-world data alone, while also reducing training risks and costs. There's no denying that Elon Musk once again delaying the Optimus launch timeline has been disappointing for those who were expecting a major presentation before the end of March, a milestone Tesla had previously hinted at in its Q4 2025 earnings report.
We'll probably unveil Optimus 3 in a few months, and I think it's going to be quite surprising to people. It's an incredibly capable robot.
Although Elon Musk hasn't given a specific launch date, the phrase final polishing stages suggests that a major unveiling event could be just around the corner, possibly sometime in April. Tesla is known for holding its major demos to extremely high standards. And after the big leap in control and dexterity we saw from Gen 1 to Gen 2, expectations for Gen 3 are sky high. This week, Optimus has even been spotted working at the Tesla diner in Los Angeles, moving around and performing basic tasks for onlookers. A lot of humanoid robotics companies today have already demonstrated robots operating in both industrial and home environments, from warehouses and factories to kitchens and living rooms. But safety is still a big unresolved issue, especially in household settings. So the question is, how serious are the safety challenges for humanoid robots? When people ask when we'll see humanoid robots in homes, we think the better question is, when are they safe? Not when they're capable enough or cheap enough. If they're not safe, they won't be in homes, because no one's going to buy one. That's why Elon Musk has repeatedly emphasized the importance of making Optimus 3 a truly safe robot. Now, we can tolerate less safe robots in factories because we're used to managing dangerous equipment with safety zones, lockouts, and strict procedures. But at home, it's a whole different story. You could try saying, "Hey Optimus, only operate in this room when no one else is inside," which reduces risk since walls and closed doors basically act as safety barriers. But making sure no pets, kids, or someone else accidentally walks in, that's almost impossible. The safety of Optimus Gen 3 is one of the top priorities that both Tesla and Elon Musk consistently emphasize. Musk has repeatedly stated that humanoid robots must reach a higher level of safety and security than any product Tesla has ever built, because Optimus isn't just a moving machine, but an AI system that can see, hear, think, and act directly in human living and working environments. The safety risks with Optimus are significantly greater than with self-driving cars or typical smart devices. A software bug or cyber attack could lead to real-world physical consequences, moving at the wrong time, applying incorrect force when grasping objects, or providing inappropriate assistance to elderly users. That's why Tesla is likely to implement multiple layers of protection, such as military-grade data encryption, real-time system monitoring, automatic emergency shutdown mechanisms when anomalies are detected, and secure remote control systems that allow humans to intervene instantly. On top of that, since Optimus continuously learns from real-world data and receives over-the-air updates, Tesla tightly controls training data sources, learning processes, and software updates to prevent unintended behavior. Initially, the robot will be deployed internally within Tesla factories to gather data and validate safety before expanding into consumer environments. Will humanoid robots ever reach human-level dexterity? Yes, they will. We just don't know exactly when. Once they become useful, they'll keep improving over time. We might not see truly superior dexterity across a wide range of tasks until sometime in the mid-2030. That said, it's easy to fall into the trap of thinking robots need the exact same sensory systems as humans, but that might not be true. They could function perfectly well with lower-level sensors, or even without certain types of sensing altogether, much like how humans adapt to reduced abilities over time. Right now, there's a serious labor shortage across a lot of industries. It'll take time before there are enough robots to make a meaningful impact, mainly because these are jobs people don't really want to do. Robots will still be limited by their capabilities. They won't be able to do everything. What that means is more people may shift into other roles. For example, if you had to choose between working in an Amazon warehouse or a nursing home and both are understaffed, robots could start taking over the warehouse jobs. That would free up more people to work in nursing homes, where tasks might still be too complex for humanoid robots. When it comes to Optimus, we see two major concerns so far. First, while there has definitely been progress, most of it hasn't been demonstrated through detailed, real-world tasks. Tesla has released very few demos, and there are still big gaps. With such an impressive robotic hand, why not show it doing something concrete, like peeling an egg, washing dishes, or even just tearing a piece of paper? That's something we're genuinely skeptical about, because we don't want to assume that everything Tesla has shown so far is just low-value demos. The second concern is, why haven't we really seen Optimus doing actual work inside factories? That's a bit confusing. Sure, we've seen it carry battery trays and do some basic sorting, but that's about it. Elon Musk has said that this year, most Optimus units will be used internally and deployed in Tesla factories. So the real question is, what exactly will Optimus be doing on those production lines? Other humanoid robots like Atlas from Boston Dynamics, Figure 02, and several Chinese robots have already demonstrated the ability to handle large automotive metal parts in factory settings. Meanwhile, Tesla has countless factories and production lines, with plenty of stations to test these capabilities. So why haven't we seen any real demo videos? When we look at humanoid robots like Optimus, we're clearly facing a double-edged sword. On one hand, the technology promises to eliminate dirty, dangerous, and repetitive work. On the other, it raises concerns that millions of human jobs could be replaced. This isn't the first time humanity has faced that fear. From the Jacquard loom in the 18th century to the assembly lines pioneered by Henry Ford, and later waves of industrial automation. History shows that every major technological leap comes with deep labor shifts. There are currently two opposing viewpoints about the speed and scale of impact. One side believes robots will replace jobs exponentially almost overnight, causing massive unemployment. I don't agree with that. In reality, the world is already facing serious labor shortages across many sectors, from logistics and manufacturing to healthcare and services. Deploying humanoid robots at scale won't happen as quickly as people think. Even if Tesla starts producing Optimus Gen 3 by summer 2026, it will still take years to reach volumes large enough to create a noticeable impact across the economy. On top of that, robots have clear limitations. They'll excel at repetitive, physically demanding, and dangerous tasks that humans don't want to do, but they'll struggle with jobs that require fine dexterity, ethical judgment, emotional intelligence, or complex human interaction. For example, if robots start taking over roles in Amazon warehouses where labor shortages are severe, it could free up human workers to move into other areas that desperately need people, like elderly care, education, or healthcare. These roles often require empathy, adaptability, and the ability to handle unpredictable situations, things humanoid robots still can't fully replace. In the end, humanoid robots aren't necessarily a threat that will replace all human labor. Instead, they could become powerful tools that complement human work and boost productivity. The real challenge isn't the technology itself, it's how we prepare our policies, education systems, and mindset to adapt to this shift. So, do you think Tesla Optimus will have a positive or negative impact on society in the long term? Drop your thoughts in the comments below. Tesla has 4 of the world's largest electric vehicle gigafactories, and they can build a car in under 35 seconds. Now, Tesla is preparing to launch what could become the largest chip manufacturing facility in the world, one that may significantly disrupt the industry. What's concerning is that traditional automakers will face enormous pressure as Tesla drives chip production costs down to extremely low levels, while they still have to rely on intermediaries and pay higher prices. Elon Musk has little choice but to produce chips in-house. To move at the speed he wants, depending on external suppliers would slow his companies down, especially Tesla. That's why Terafab is essentially a computing infrastructure empire, set to produce 2 of the most powerful chips in history. Inside the Terafab factory, the scale and technology could be shocking. Even top semiconductor experts might be stunned. Let's break down the 2 super chips that will be made there. Whether you like Elon Musk or not, it's hard to deny his ability to build massive manufacturing operations, from EV gigafactories across continents to lithium refineries, battery production plants, energy storage facilities, and the world's largest charging network, and now, the Terafab chip manufacturing plant. We believe many of you don't fully understand what Terafab actually is. Put simply, fab is a term used for semiconductor manufacturing plants where microchips and billions of chips this factory produces each year could reach 1 terawatt, whereas the circuit boards are produced while tera comes from terawatt, referring to extremely large levels of energy. According to Elon Musk, the total computing capacity of the total electrical capacity of the entire United States today is about 0.5 terawatts per year. To make that easier to visualize, if we imagine the entire US power grid as one giant light bulb illuminating a continent, then the total computing power of the chips produced by this factory in a single year could light up 2 such continents at the same time. In other words, it goes far beyond almost anything we can realistically imagine. So why is Elon Musk essentially forced to build Terafab? When Tesla was first founded and launched the Roadster, Model S, and Model X, it was primarily an electric vehicle company. The chips used in those cars were for basic systems like battery management, motor control, and infotainment. These were standard chips, purchased from major suppliers like NVIDIA, Intel, Infineon, or Bosch. The volume wasn't large since each vehicle only required a few key chips, and Tesla's production at the time was still small, just a few thousand to tens of thousands of cars per year. At the same time, Tesla didn't yet require advanced AI or real-time video processing. Early autopilot was only a level 2 driver assistance system, using Mobileye chips or relatively simple hardware. Between 2019 and 2022, Tesla began to transform with Hardware 3, its first in-house designed chip for full self-driving. However, chip demand still hadn't exploded. Vehicle sales were growing but remained under 1 million units per year. FSD primarily handled inference on the car itself, while AI model training still relied on NVIDIA GPU. Tesla also started developing the Dojo supercomputer with its D1 chip to reduce dependency, but its computational scale was still limited, as the volume of collected video data hadn't yet reached the massive petabyte levels seen later. At that time, AI wasn't Tesla's core business. It was more of an added feature to its electric vehicles. As a result, the company could still rely on suppliers like TSMC, Samsung, or NVIDIA, without facing major bottlenecks in supply or cost. So what changed? We believe the fundamental shift began around 2023, when Tesla started aggressively repositioning itself as an AI and robotics company. With plans to deploy millions of robotaxis, manufacture millions of humanoid robots like Optimus, and develop unsupervised, full self-driving. Each vehicle or robot now requires powerful chips capable of processing data from dozens of cameras in real time. At the same time, training AI models demands the equivalent of hundreds of thousands to millions of GPUs. Meanwhile, SpaceX is aiming to build orbital data centers to process AI directly in space, reducing latency and optimizing energy usage. These systems would rely on radiation-hardened chips operating in extreme environments, potentially delivering hundreds of gigawatts to terawatt-scale computing power. Combined with efforts from xAI, the total chip demand across Elon Musk's ecosystem becomes enormous, far exceeding the current capacity of the global semiconductor industry. So how exactly is Tesla facing a chip shortage? According to estimates, the current chip supply from major manufacturers can only meet about 3% of the future demand from Elon Musk's companies. If they continue relying on external suppliers, costs will skyrocket, lead times will stretch out, and the risk of supply chain disruptions will remain ever present, just like what happened during the pandemic and amid geopolitical tensions. Musk has acknowledged and expressed gratitude to existing partners, including Samsung, TSMC, Micron, and others. However, continued dependence on companies like TSMC or Samsung would create bottlenecks in cost, delays, and supply stability, something unacceptable when trying to scale at an insane pace. That's why Terafab is extremely urgent and is being rapidly developed. So what's inside the Terafab factory, and how will it operate in such a radical way? Terafab is being built in the northern section of Giga Texas and is designed to unify every stage of semiconductor production under one roof: chip design, lithograph, fabrication, memory production, advanced packaging, and testing. This is a highly strategic move that optimizes development speed, operating costs, and integration across Elon Musk's companies. First, Giga Texas serves as the global headquarters of Tesla and is also its largest manufacturing hub for the Model Y, Cybertruck, and soon robotaxis and the Optimus. Placing the initial phase of Terafab, known as the Advanced Technology Fab, spanning roughly 2 million square feet, right at the north campus of Giga Texas, allows Tesla to achieve an ultra-fast chip development loop. Engineers can design chips, create lithography masks, produce test wafers, run validation, and fix issues in just a matter of days, instead of weeks or even months, if these steps had to be spread across distant facilities. This creates a massive competitive advantage in the semiconductor industry, where iteration speed can determine survival. Yeah, it's no coincidence that Giga Texas is considered Tesla's flagship factory. Although it produces multiple vehicle models, its real advantage lies in its high level of automation, along with some of the most complete infrastructure for electricity, water, and logistics. The Austin, Texas area offers abundant and competitively priced power, and Tesla is also heavily investing in renewable energy. Terafab is expected to require enormous power, potentially exceeding 10 gigawatts at full scale, and being located near Giga Texas makes it much easier to integrate with existing energy infrastructure. In addition, North Austin, Travis County already has expansion permits, available land, and a business-friendly policy environment from the Texas government. The region is also attracting major semiconductor projects, such as Samsung's facility in Taylor, which is not far away. But that's not even the biggest advantage. What many people don't realize is that Giga Texas concentrates some of the most talented engineers and executives across all of Tesla's factories. Terafab stands to benefit enormously from being built here, not just by leveraging talent and infrastructure, but also by placing chip production right next to vehicle and robot assembly. This reduces transportation costs, shortens logistics timelines, and increases flexibility in updating hardware. However, Elon Musk has made it clear that the full terafab facility will span around 100 million square feet, roughly 10 times the size of Giga Texas, and require thousands of acres of land, making it impossible to fit entirely within the existing campus. The scale is simply too massive. That's why only the advanced technology fab focused on rapid prototyping and design iteration is being built adjacent to Giga Texas, while other locations are being considered for full-scale mass production. Terafab is ultimately expected to reach a staggering scale of around 100 million square feet. Industry observer Phil Beazle has outlined a preliminary framework for what such a terafactory might look like. The reason this much space is needed comes down to Tesla's ambitious goal, achieving 1 terawatt of AI computing power. If we assume each chip operates at roughly 250 watts, reaching 1 terawatt would require producing around 4 billion chips per year. Manufacturing that volume using current semiconductor processes would demand thousands of acres of land and potentially hundreds of millions of square feet of production space. Okay, so what does 100 million square feet really mean? A manufacturing facility of that size would be unprecedented in industrial history. Its sheer scale would make even today's largest factories, including Tesla's gigafactories, look small by comparison. For perspective, Gigafactory Texas, already one of the largest buildings in the world, has about 10 million square feet of floor space. That means terafab would be roughly 10 times larger. You know, even compared to famous tech campuses, terafab would dwarf them. Apple Park offers about 2.8 million square feet of office space, while Microsoft Redmond campus spans over 8 million square feet across dozens of buildings. Terafab would be about 35 times larger than Apple Park and roughly 12 times larger than Microsoft's entire Redmond campus. To put it in more vivid terms, that's roughly 3 times the size of the City of London, or comparable to the combined area of Vatican City, Monaco, and Gibraltar. But beyond the jaw-dropping scale, the key point is this terafab isn't designed for today's chip demand. It's built for the future, aimed at meeting massive AI chip needs for self-driving vehicles, the Optimus, orbital data centers, and advanced projects from Tesla, SpaceX, and xAI. Now, let's step inside terafab. What technologies will power it? And what are the 2 breakthrough chips set to be produced there, if 3 nanometer and 4 nanometer chips are already mainstream? Terafab is aiming for the 2 nanometer process node, the most advanced level right now. Elon Musk says terafab will use gate-all-around transistor technology to make chips that are smaller, more power efficient, and more powerful than today's common 3nm/4nm chips. On top of logic chips, the factory will also produce high-bandwidth memory Gen 4 at the same time. This is high-bandwidth memory built specifically for AI, offering way higher speed and capacity than high-bandwidth memory Gen 3. Advanced packaging and testing are fully integrated, so large-scale chip packaging can happen right on site without handing things off between different suppliers. There's also a small R&D lab on campus that tests new ideas daily, cutting development cycles from months down to just days. Terafab will focus on producing exactly 2 main types of chips, each handled by its own fab. First are next-gen AI inference chips, AI5 and AI6. These act as the brains for real-world applications, powering Tesla's full self-driving, the robotaxi Cybercab, and the humanoid robot Optimus. Instead of relying on expensive sensors like LiDAR, Tesla uses a pure Tesla vision system, where the AI chip crunches billions of calculations per second to turn raw image data into an accurate 3D spatial map. For robotaxi, the chip doesn't just recognize lanes or traffic signs, it also predicts the behavior of people and surrounding vehicles, ensuring safety through a dual redundancy processing system. For Optimus, the AI chip takes on even more complex tasks, like managing balance and coordinating precise movements across dozens of mechanical joints. Thanks to a unified AI architecture, improvements in self-driving can be directly applied to help the robot learn new skills through observation. The key advantage of Tesla's in-house AI chips is how well they optimize performance per watt. That's critical for battery-powered devices, extending operating time without sacrificing the performance of massive neural networks. AI5 is expected to start limited production in 2026 and ramp up to mass production in 2027, while AI6 is projected to be twice as powerful on the same chip. These chips are designed to support hundreds of millions of Tesla vehicles and potentially billions of Optimus robots in the future, helping Tesla lead the self-driving and robotics revolution. The second type is the D3 chip. This chip is specifically built for the harsh environment of space, able to withstand high radiation, energetic ions, and accumulated electrons. Unlike typical chips, D3 can operate at higher temperatures, which reduces the need for heavy cooling systems. That makes next-gen Starlink satellites and orbital data centers lighter and cheaper to launch. D3 is expected to make up the majority of production, effectively turning space into a massive supercomputer, far more cost-efficient than building traditional data centers on Earth. Putting AI data centers in orbit doesn't just solve power consumption and cooling issues on the ground. It also takes advantage of Starlink for fast data transmission, compared to existing chip fabs. Terafab stands out in both scale and approach. Fabs run by companies like TSMC or Samsung are typically multi-purpose, serving hundreds of different customers, which leads to complex processes and long changeover times. Terafab simplifies things by focusing on just 2 chip designs, while also integrating memory production and packaging, something rarely done. On the tech side, 2 nanometers and HBM4 put Terafab on par with, or even ahead of competitors. But its biggest advantage is the speed of design iteration enabled by vertical integration. The production targets are pretty wild. Terafab is designed to start at around 100,000 wafers per month, with the ambition to scale up to 1 million wafers per month at full capacity. To put that in perspective, that full capacity goal would be roughly 70% of TSMC's current total global output, from a single facility run by companies that haven't traditionally manufactured chips before. Musk says this facility could produce between 100 and 200 billion custom AI and memory chips per year, powering Tesla's full self-driving software, the Cybercab robotaxi program, and the Optimus Humanoid robot lineup. He also claims millions of Optimus robots will help build and operate the facility itself. About 80% of Terafab's compute output is expected to go to AI satellites in orbit, with only 20% used for ground-based applications. Elon Musk argues that solar radiation in space is about 5 times higher than on Earth, and that cooling in a vacuum actually makes thermal scaling more feasible. His conclusion: orbital AI computing could become cheaper than Earth-based alternatives within the next 2 to 3 years. Okay, so we've heard the big vision and what's supposed to happen inside Terafab, but what about the challenges? Yeah, there are quite a few serious hurdles. From an economic and engineering standpoint, the initial cost of $20 to $25 billion could rise to $35 to $45 billion. According to Morgan Stanley, building just a single 2-nanometer fab already costs around $28 billion and takes about 38 months just for construction in the U.S. Terafab isn't just one fab, it's 2 massive specialized fabs, requiring over 10 gigawatts of power and thousands of acres of land. TSMC has committed $165 billion for 6 fabs in Arizona and still isn't expected to reach 2 nanometer until around 2029. For Tesla, this investment goes far beyond its projected $20 billion capex in 2026, potentially diluting profits and forcing additional fundraising at a time when growth is already slowing. Second, lack of semiconductor manufacturing experience is probably the biggest barrier. Tesla has never operated a chip fab, while the semiconductor industry demands extreme cleanliness, ultra-expensive EUV machines, and highly complex supply chains. Just look at Battery Day 2020. Musk promised 4680 cells would cut costs by 50% and reach 3 terawatt-hours by 2030. After 5.5 years, the dry electrode process had to be revised 6 to 7 times. Production is only around 2% of the target, and Tesla's largest battery supplier even said, Elon doesn't know how to manufacture batteries. And battery production is already hard. 2-nanometer chip fabrication is exponentially harder. Early yields percentage of working chips are usually low, which can mean heavy losses for years. Third, the timeline and execution risks are huge, even under ideal conditions. Construction alone takes 3 to 5 years. AI-5, the inference chip for robotaxi and Optimus, is expected to reach mass production in 2027, but will almost certainly still rely on TSMC or Samsung, not Terafab. Meanwhile, the robotaxi race is entering a critical 1 to 2 year window, with players like Waymo and Zoox already pushing rapid commercialization. Terafab risks being too late to create a short-term competitive edge. Finally, the orbital data center model, where 80% of D3 chip output goes to space, is the boldest and riskiest part. Radiation-hardened chips must survive cosmic radiation, high-energy ions, and operate at higher temperatures to reduce cooling needs, something never done at massive scale. Deploying millions of satellites via Starship requires continuous launches, stable laser data links, and effective thermal management in a vacuum. No one has successfully done this at terawatt scale, so technical failures and cost overruns are very real risks. That said, Terafab isn't just a factory, it's a strategic turning point that could let Tesla, SpaceX, and xAI fully control their semiconductor stack. By owning everything from design to manufacturing, they could accelerate innovation in AI, humanoid robots, self-driving, and space-based data centers. If it works, Terafab won't just reshape the semiconductor industry, it could help realize Elon Musk's vision of a multiplanetary species. The project is still in its early planning stages, but given its scale and ambition, it could become one of the most significant industrial undertakings of the 21st century. The future of AI and space exploration might very well be shaped in Austin, Texas, where Terafab is gearing up to change everything.
So this truck can charge at 1.2 megawatts.
Right.
And so we can recover about 60% in 30 minutes.
Wow,
So
30 minutes.
2 years ago, Jay Leno got to experience the Tesla Semi and even pulled one Tesla Semi with another. That meant the truck was able to tow over 20,000 pounds without any issues. Even more interesting, it uses an automatic regenerative braking system to store and recover energy, which makes everything, including braking, feel smoother, even when braking. Jay Leno said it didn't feel like he was pulling a heavy load behind him. Based on the overall experience, he believed this truck could mark the beginning of a revolution, and that video racked up 3.3 million views. When the refreshed version of the Tesla Semi was unveiled, Jay Leno once again got behind the wheel to test and review the truck before it goes into mass production. The upgrades, improvements, and added features were revealed in great detail, including a new battery capable of lasting up to 1 million miles. Now, let's take a look at what the improved 2026 version has changed compared to the prototype from 2 years ago. Yeah, Jay Leno was the first person outside of Tesla to sit behind the wheel of the new production version of the Tesla Semi. Just like last time. This test drive also featured Franz von Holzhausen, Tesla's chief designer, and Dan Priestley, head of the Semi program. First of all, thanks to Jay Leno, we learned that the new Tesla Semi has cut out 1,000 pounds compared to the previous generation.
we cut about 1,000 pounds out of the truck. And this long-range truck, the 500-mile version, is about on par.
Okay. We've learned that this weight reduction isn't just a simple number, it's the result of a fully optimized chassis design, the use of advanced composite materials, and smarter battery integration. In the traditional trucking industry, every extra pound increases fuel consumption and reduces payload capacity. With the Semi cutting 1,000 pounds, about 453 kilograms, makes the truck more agile in operation, especially on hilly terrain or long highway routes. Looking deeper, this reduction allows the Semi to reach a full gross vehicle weight of 82,000 pounds, the standard for diesel trucks, without sacrificing range. This becomes even more significant when combined with the 2,000-pound exemption granted to electric vehicles in certain U.S. states, making the Semi a direct competitor to diesel trucks in terms of real-world hauling capability.
From the last time we saw you, it's a 7% improvement on the aero efficiency from before. So it's the CD is about 0.4.
Next is a 7% improvement in aerodynamic efficiency. This is a major leap compared to traditional trucks, where aerodynamic drag accounts for as much as 50 to 60% of energy consumption at high speeds. By refining the cab design, replacing side mirrors with integrated camera systems, and smoothing out the body lines, Tesla has significantly reduced air resistance. As a result, the Semi delivers noticeably better energy efficiency over long distances, especially when fully loaded. A closer analysis shows that this 7% gain can translate into hundreds of additional miles of range per charge, or substantially lower operating costs for cross-country routes. In the context of fluctuating electricity prices, this becomes a strategic advantage, helping the Semi compete with diesel, where fuel alone can account for 30 to 40% of a truck's total operating cost. The most standout highlight is its drag coefficient of just 0.4, compared to conventional diesel trucks, which typically range from 0.6 to 0.8. The Semi's 0.4 is comparable to many high-end passenger cars. This figure, validated through wind tunnel testing and real-world trials, shows that the Semi's aerodynamic design has reached an unprecedented level in the heavy-duty truck segment. From a performance standpoint, a lower drag coefficient directly reduces air resistance, lowering the power required and improving overall efficiency. For operators, this means less wasted energy, more consistent range, and reduced maintenance costs due to lower aerodynamic stress. Additionally, Dan Priestley confirmed that the Semi does not require special or custom tires. Standard off-the-shelf tires, widely available on the market, are fully compatible. This is a major advantage, as heavy-duty truck tires are typically expensive and can take a long time to replace if they need to be specially ordered. With the Semi, operators can source tires from any supplier like Michelin or Goodyear, reducing maintenance costs and improving availability. From a practical standpoint, this helps minimize downtime and makes the Semi more accessible to smaller, independent repair shops, not just authorized service centers, like Tesla's passenger vehicles. The Semi is equipped with an advanced regenerative braking system, and it's extremely impressive. When braking, the electric motors convert kinetic energy back into electricity and store it in the battery, instead of wasting it as heat like traditional friction brakes. In terms of efficiency, regenerative braking can recover up to 70 to 80% of energy in urban driving or on hilly terrain, playing a crucial role in extending range and reducing wear on mechanical brakes. For heavy-duty trucks, where frequent braking is necessary due to large loads, this feature not only saves energy, but also significantly extends brake life, lowering long-term maintenance costs.
So we have two axles. We have the torque axle on the front, and that's geared for acceleration, for hill climb, those big power maneuvers. And then we have a separate axle that is geared for efficiency.
Dan Priestley also pointed out something pretty interesting. Unlike traditional diesel trucks that rely on complex multi-speed transmissions to balance high torque at low speeds with efficiency at higher speeds, the Tesla Semi doesn't use a multi-gear gearbox at all. Instead, it uses two separate rear axles, each designed for a different job. The front axle. Basically, the torque axle is built for strong acceleration and climbing hills. Once the truck reaches highway speeds, that axle automatically disconnects internally to eliminate mechanical drag. Then the separate efficiency axle takes over completely for cruising on the highway. By disconnecting the torque axle, the Semi cuts down mechanical energy losses, helping it use only about 1.7 kilowatt-hours per mile, even when fully loaded. On top of that, each axle gets to operate in its own sweet spot. The torque axle focuses on raw power, while the efficiency axle is all about saving energy. The result is a real-world range of around 325 to 500 miles, depending on the version. This approach cleverly solves one of the core challenges of electric trucks, the trade-off between having enough low-speed torque to haul heavy loads uphill and maintaining efficiency at high speeds for long highway trips. As for steering, the Tesla Semi completely ditches traditional hydraulic assist and switches to a fully electric power steering system. That's a big upgrade, since hydraulic systems need regular maintenance, can leak fluid, and waste energy. With electric assist, the Semi delivers more precise, smoother steering feel and integrates much more easily with advanced driver assistance features. The key thing is, this isn't a pure steer-by-wire system with no mechanical link between the steering wheel and the wheels. It still keeps a physical connection to maximize safety, which is a smart call in the heavy-duty truck segment, where reliability is absolutely critical. From a technical standpoint, switching to electric assist helps cut overall weight, contributing to that earlier 1,000-pound reduction, while also improving energy efficiency and simplifying maintenance. What's especially interesting is that the Semi uses steering actuators derived from the Cybertruck, but they've been seriously beefed up to handle loads of up to 82,000 pounds. The Cybertruck is already known for its advanced electric steering system, and adapting that tech for the Semi shows Tesla's strategy of sharing components across different vehicle lines. These actuators deliver high torque, quick response, and strong load-bearing capability, keeping the truck stable even when it's fully loaded or driving on slippery roads. Real-world testing suggests the new steering system makes the Semi noticeably easier to handle than traditional diesel trucks, reducing driver fatigue and improving precision when cornering or avoiding obstacles. Next up is the electrical architecture, which has clearly been upgraded on the Semi. About 2 years ago, when Jay Leno tested the Tesla Semi, it was still running on a traditional 12-volt system. So moving to a 48-volt architecture in the newer version really changes the game. A 48-volt system allows for more efficient power delivery, reducing losses in the wiring and supporting high-power components like steering actuators, the cabin infotainment system, and safety sensors. And it doesn't stop there. 48 volts also improves overall energy efficiency, makes it easier to integrate with a large battery pack, and gets the truck ready for future automation features. It also contributes to that high 95% uptime, since the electrical system is less prone to failures, while reducing wiring weight, directly supporting both aerodynamic goals and overall weight reduction.
The battery is designed to last 1 million miles.
Right.
You will see some degradation over time, but we see that it can last in its original duty cycle 1 million miles.
About 2 years ago, Tesla was using LFP batteries in the Semi, a choice aimed at lowering production costs and improving safety for an electric truck. While LFP batteries have some clear advantages, they also come with trade-offs that matter over the long run. You know, LFP stands out for its excellent safety and stable performance in cold weather. That's a big deal for electric trucks. especially in colder regions where traditional batteries can lose efficiency and degrade faster in low temperatures. LFP cells are thermally stable and much less likely to catch fire or explode, which is critical for a large vehicle like the Tesla Semi. They're also cheaper to produce compared to chemistries like NCA or NCM, but the biggest downside is their relatively low energy density. In practical terms, that means to deliver something like a 500-mile range, Tesla has to pack in more individual cells, so a 900 kWh battery pack ends up needing a higher cell count, which increases the truck's overall weight. Okay. That's why Dan Priestley confirmed that the refreshed Semi versions are moving to 4680 cells. These have nearly double the energy density of LFP, meaning Tesla can use fewer cells per pack while still achieving the same total energy capacity. This also helps bring down the overall weight of the tractor unit. The 4680 cells use a tabless design, meaning they eliminate traditional connection tabs, which reduces energy loss and heat buildup during operation, ultimately improving both efficiency and battery lifespan. The Semi's 4680 batteries are optimized to handle the intense charge and discharge cycles of heavy-duty trucking, including the kind of energy recovery you get from regenerative braking we talked about earlier. The biggest highlight, though, is the target lifespan up to 1 million miles, something that's basically unheard of in the industry. Yeah, put that into perspective. 1 million miles translates to over 10 years of continuous use, assuming around 100,000 miles per year for an independent trucker. That's huge. Not just because it avoids the massive cost of battery replacement, but also because it gives owner-operators much more predictable long-term value, making it easier to plan profits and even secure financing from banks. On top of that, 4680 cells are now significantly cheaper to produce than they used to be, with Tesla reportedly cutting battery production costs by as much as 40%. They're also more reusable thanks to their longer lifespan and ability to handle harsh conditions while maintaining relatively stable performance, which is exactly why Tesla is also using them in the Cybertruck. Two Tesla executives also said the Semi now comes with an advanced driver assistance system, allowing it to automatically stay in its lane, maintain a safe following distance, and even step in with emergency braking if it detects a potential collision. Looking deeper, these features don't just reduce driver fatigue, especially for drivers who are behind the wheel for hours at a time. They also help lower overall accident rates on highways. Data from test fleets shows Tesla's safety systems allow the Semi to operate with minimal driver intervention, while still staying fully compliant with mandatory rest time regulations. The driver's seat is also purpose-built, with memory positioning, power recline, and an auto-retracting seatbelt to improve protection in the event of a crash. Even though heavy trucks aren't always required to have airbags like passenger cars, Tesla goes further by optimizing the cabin structure to absorb impact energy, protecting both the driver and the cargo. Another really promising area is wireless charging, which Tesla is actively developing for the Semi. According to Dan Priestley, in the near future, drivers could simply drive over a charging pad and the system would automatically start charging. No need to plug anything in. This tech, being developed alongside Tesla's Cybercab, uses conductive or inductive methods to efficiently transfer power to the Semi's large battery pack. From a practical standpoint, wireless charging could be a game changer for fleet operations. Less downtime at charging stations. No need for drivers to get out and plug in, especially in bad weather, and it's perfect for fixed routes like warehouse to distribution center runs. For independent truckers, it means more convenience and tighter scheduling without worrying about complex charging infrastructure. That said, there are still technical challenges to solve, like energy transfer efficiency, which could reach around 90 to 95% compared to wired charging, and the upfront installation costs. But if Tesla pulls it off, wireless charging could significantly accelerate the shift from diesel to electric trucks, especially in urban areas and ports where trucks make frequent stops. When it comes to real-world operating data, even though the Tesla Semi fleet is still relatively small, just a few hundred trucks, it has already racked up over 13.5 million miles. That's a big enough number to move beyond the testing phase and into proving real-world viability. What's interesting isn't just the total mileage, but how it's distributed. On average, each truck is logging tens of thousands of miles per year, which shows consistent, high utilization. This creates a valuable data foundation that allows Tesla to continuously optimize both software and hardware through over-the-air updates, basically creating a feedback loop of constant improvement that traditional vehicles just can't match. An even more compelling example is the lead truck in the fleet, which has already hit 440,000 miles on the odometer. That's not just a symbolic milestone, it directly reflects the durability of the electric drivetrain and battery system. When you compare that to diesel trucks, which typically require major overhauls somewhere between 300,000 and 500,000 miles, the Semi is showing real potential for a longer service life thanks to its simpler mechanical design, fewer moving parts, and fewer wear points overall. In other words, the advantage of electric trucks isn't just about energy costs, it's also about superior mechanical longevity. Operational performance backs this up even more. The fleet is reporting around 95% uptime, significantly higher than the typical 80 to 85% you see with diesel trucks, and that's not a small gap. It translates directly into economic value. Every extra percentage point of uptime means more deliveries, higher revenue, and fewer disruptions. The main reason comes down to minimal maintenance requirements, no oil changes, no complex fuel systems, no internal combustion engine tuning, so both downtime and maintenance costs are dramatically reduced. Finally, operational efficiency really shows up in how issues are handled. About 75 to 80% of breakdowns are fixed, and the truck is back on the road in under 24 hours. That's not just a service win. It's the result of a fully integrated digital ecosystem, from remote diagnostics and over-the-air updates to parts logistics. From a business standpoint, that kind of fast turnaround massively reduces losses, since every day a truck is down can mean thousands of dollars in missed revenue. Even though it took nearly a decade from the first concept reveal, looking at the real-world performance and engineering achievements of the Tesla Semi today, it's fair to say the wait has been worth it. This is no longer just a tech experiment. It's quietly but decisively redefining the standards of long-haul trucking. From its smart dual-axle drivetrain, ultra-low drag coefficient, durable 4680 batteries targeting a 1 million mile lifespan, and 95% uptime, to real accessibility for independent truckers. It all paints a picture of a future where electric trucks aren't just cleaner, but also cheaper to run, more reliable, and even more enjoyable than traditional diesel rigs. Jay Leno even called the Tesla Semi one of the biggest leaps in transportation since trucks replaced trains. He described driving it as basically like driving a regular Tesla car, super easy and genuinely fun, with instant torque and strong acceleration without any gear shifting. He was also impressed by the tight turning radius, optimized aerodynamics, spacious cabin with great visibility, and the center driving position, which he said feels surprisingly natural. What stood out most to him, though, was the significantly lower operating cost, the 1.2 megawatt fast charging capability, and the battery's potential 1 million mile lifespan. In his view, the Tesla Semi could realistically replace diesel trucks in the near future. And that wraps it up for today. So here's the big question: when a truck can run hundreds of thousands of miles with lower operating costs, longer lifespan, and better safety for everyone on the road, does the global logistics industry really have any reason left to say no? What do you think about the Tesla Semi drop? A comment below. Thanks for watching.